Hi everyone, in this video I will explain a project road accident analysis using ML and data analysis. For that we have to download a dataset. Here I am using Kaggle website for downloading a dataset. So as our project is road accident analysis, I am downloading the dataset called US accident dataset. So you can click on this link, then it will show a download button here. You can click on this button. Here it shows that download dataset as zip. Here you can click on this and download the dataset as in zip format. As I already downloaded the dataset, you can download on your own. So in this dataset, it contains 7.7 million accident records. So the data is huge. It is unable to open in our systems, and this dataset contains the features like source, severity, temperature, start time, longitude, latitude, etc. So for to load this in our notebook, we have to trim the dataset. So for trimming, I will show the code in the notebook. This is the code for the trimming. So first we have to import the pandas. It is used to handle the data frame and for reading CSV files. This is the path of our downloaded file. Here we used R for raw path. Here we want up to 1 lakh records. So we take n equal to 10,000. It will store it in the trimmed data frame. So this data frame will convert to CSV file using 2 CSV, and the file is named as US accidents trimmed 1 lakh CSV, and we are printing the top 5 data in the trimmed data frame. So we have to connect the data frame with our code. So for that we used PostgreSQL. Let me explain how to work with PostgreSQL. This is our default workspace. It has databases. In database we created a Postgre as our database name. Here we have a tables. Here these are the tables. This is the query tool. We can write queries in this query box. In query history, we already created our table called US accidents new. We have written a query, create table with the table name US accidents new with attributes which are the features in our dataset. This is the query to connect our notebook and our PostgreSQL database. This is the path of our trimmed dataset. Here we can run a query to see our new table US accidents new. For that you write a query in query tool. Just run this query. Here this is our dataset with 1 lakh crores. This is our trimmed dataset of our project. These are these are the libraries we used for our project. Pandas is used for handling C- data frames and for reading CSV files. This is for data visualization. Matplotlib is used for plotting. This PSY Corp G2 for Postgre. Create engine is used for connecting the PostgreSQL with our notebook. Base map is used for generating a heat map, and our map, geographical map. A priori and association rules is imported from ML extend frequent patterns. It is used to a priori is used to generate frequent patterns, and association rules is used to generate the rules. Here, by using create engine, we are connecting the PostgreSQL database to our notebook. This is the password is asked when we are downloading the PostgreSQL, and it is connected or not. We are verifying with read SQL query. We are printing the top five data records in the data frame. Here we are removing the columns having more than 50% of null values. Next, we are dropping that null value rows. df info gives the information about our data set. Here we contain 0 to 9998 records, and we are in our data set we have for up to 45 columns. In our data set, data types are bool, data type, object, and int64 and float. If the data type is object, we are filling it with mode. If it is other than object, we are filling with median. This is the top 5 records of our data frame after filling the missing values. This is used if after filling that missing values, we are mm, creating a table us accidents cleaned due in our PostgreSQL. If it is there in the PostgreSQL database, it will just replace the data. If it does not exist, it will create in the PostgreSQL. Here we plotting the graph of accident severity. In x-axis we take severity and count it. Most accidents are happened at the count of 2. Here we plotting based on weather conditions. Based on weather condition, we plotted up to 10 weather conditions. At fair condition, most of the accidents are happened. Next, we are plotting the top 10 states by number of accidents. We are plotting the states which have most number of accidents. CA has the most number of accidents in the US state. Next, we are plotting the graph for number of accidents per time zone. So if the time zone is East, Eastern US Eastern has more number of accidents compared to other time zones. Next, we gave a colors for each time zone. For US Eastern, we give green color. Similarly, we give for different colors for different time zones. Next, we plot it a graph. Here we used base map for plotting the US map. So after plotting the US map using base map, here it is showing that green represent the US Eastern. It tells that US Eastern have major number of accidents, and then US Pacific has most number of accidents. Next, we generating association rules for uh, boolean features like junction, traffic signal, railway crossing, station stop, and categorical features like sunset and weather condition. For these features, we are generating a associate frequent patterns and association rules. Here we used one hot encoding for converting the categorical data into numerical data. Next, we combining that in df encoded. Next, we generating the frequent item set using a priori Here minimums we gave minimum support as 1%. Here we generating association rules by using association rules. Here we gave minimum threshold as 0.6 point 0.6 for the confidence. Next we are printing association rules. Here we can see if junction then sunset right sunset day has 62.66 percentage of the confidence which is greater than the 0.6 point 0.6. So we, this is the acceptable association rule. So we are plotting the graph based on the streets in the US. So we are plotting the streets for top 20 streets. So we take number of accidents on x-axis and street name as in y-axis. I-95N has the major number of accidents in compared to other streets. Now we are plotting the graph for weather condition and sunrise sunset. In weather condition we are taking the top 8 conditions. In x-axis we are taking the weather condition and in y-axis we are taking the percentage of total records. In the graph we are displaying the uh, total percentage in day and night for that corresponding weather condition. Next, for the same above weather condition time of the day graph, we are generating the heat map using Seaborn for uh, perfect and clear visualization. Here it clearly shows in horizontal we are taking the weather condition like cloudy, fair, fog. In mm, vertical like in horizontal rows we are taking day and night. In columns we are taking cloudy, fair for clear representation. So this above representation can be visualized in Power BI also. Let me show how it works in Power BI. Power BI tells the clear visualization. The main advantage in Power BI is here we can see only the uh, some features only. In Power BI we can see all the features. So we are getting data from the another source. So click on that. So next we are connecting it from the Postgre database. So select the Postgre database and connect. So our server is localhost and its port number. Port number is 5432. Database Postgre. If you don't know your database in the Postgre, you can see in the default workspace databases Postgres. Postgre is the database name. So click on OK. So our table name is US accidents new. Select this and load it in the Power BI. So you will see that loaded data right side of the screen. As our data set is long, it taking time to load the data set. All the 1 lakh rows are loaded, so it will load on the right side of your window. So this is our the table, this is our columns in the table. So here we can draw a graph. Here let's select the sunrise column and put it here. So you can visualize the data. In sunrise we have day and night. Let's take your if you want to use this bar graph, you can select this. On y-axis you selected this column. Let's select the same column in x-axis also. It will shows like this. At daytime, accidents are more compared to night. If you want to see another one, let's take this bar chart. Let's take another column, traffic cleaning. Cancel this. And the same traffic cleaning at y-axis. The bar graph shows like this. For road accident analysis, I already prepared a file, so you can visualize the same. You can visualize the same bar graph in this file. So it's taking the longer time to load. Sorry for that inconvenience. So we seen that sum of severity by severity. So these we can scroll like this to see all the 1 lakh rows. So this is the advantage in Power BI. So this is different graphs we represented in using Power BI for road accident analysis. Let's see the models implemented for our for predicting the percentages using ML models. So here we used random forest model and logistic regression. So random forest datasets divided into subsets. So each subset generates different uh, decision trees. So we take the output based on the majority votings. If it is numerical, we take the average. In logistic, it builds a linear relationship between independent and dependent variables. So here in random forest, it assumes all features are independent. So we take a with atmospheric features for training the model like temperature, humidity, visibility, wind speed, precipitation. So for it is a label data set, so we need an class label. So we take accident as class label, and for all the rows we take class as 1, and we take random samples and make it as 0 class. Next we take full data variable and we concatenate those random samples into the actual samples. Next we splitted the data of test size zero point 0.2. So by using fit we trained the data. For random classifier we used the fit for training the data, and logistic also we trained by using fit. Here it's showing some warnings, please avoid that. Let me run it and show. It will take some time as our data set is long. So let me explain the prediction, how to predict the accident possibility percentages in percentages for each model. We here we used dot predict for predicting for new data. This code will run after completion of implementation of this block. Here we give input values like temperature as 37, humidity as 23, visibility as 4. Based on that it will calculate the accident possibility. For the above sample, random forest predict 3% as accident possibility. Linear regression gives 65%, because linear regression builds the relationship between independent and dependent features. And deep learning, in deep learning we take the sigmoid function, I will, and activation function for training. So it will give 0% as accident possibility. So this code is taking another features in before we take atmospheric conditions, but here we taking rose road or visibility conditions like sunset weather condition. So by using the above same random feature and logistic and deep learning models, we trained for the same features and predicted the same output. This it is not running yet. Here also for training we use fit, and for predicting we use dot predict for all the models to predict the accident possibility. That's it. Thank you.